Alright, let's take a look at section 2, which is all about some properties for reminding you how to solve an equation. Basic stuff you should remember, but hey, we forget some stuff, but let's make sure we can do it all and make sure it's all right. Okay. So let's just go back and talk about some of the basic properties, postulates that you should know from real numbers. Go through them quickly just so you know what they are. We have the reflexive property, which says that anything is equal to itself, aka A is always A, 2 is always 2, 3 is always 3, doesn't matter. Okay. We have the symmetric property, which says if A equals B, well, guess what? B equals A. Doesn't matter where the equal sign is. Doesn't matter. It's all good. You can flip them. Transitivity, which is the awesomest property in the entire world, which is if A equals B and B equals C, well, guess what? A better equal C. Right? Property we should know. One of the biggest ones we use unintentionally is the substitution property, which is any property, or any quantity, I should say, can be substituted with its equal. So, in other words, when we check, that's substitution. Okay, x equals 3, you sub in 3. If it works, it works. Okay, the addition property says equals added to equals are equal. We don't have a subtraction postulate because we all know that subtraction is really addition, but just with negative numbers. Right. The other property we have is the multiplication, which is equals multiplied by equals are equal. In other words, you can multiply, and again, division, we don't have a property for that because, well, duh, multiplication, division are the same. Multiplication, or division is really just multiplication by the reciprocal. Alright, just going through some of our solution sets, we define the domain as all the set of all possible replacement values for a given variable. A lot of times you're going to see it known as it's the x coordinates. Okay? A solution set is a set of all values of the domain that satisfy the sentence. In other words, what works? The solution is what works. Okay? There are 3 types of solution sets. We have the finite set, the infinite set, and the empty set. Okay? A finite set is a set in which the elements or the members can be counted. Okay? We have lots of these. These are what you do in 8th grade. Anything that has this, x equals 3, x equals 4, it has a spine number. You can count them. Okay, the domain is the counting numbers, okay? For this problem here, actually, if the domain is the counting numbers, there is no answer to it. So actually, I know in my notes I have the domain is the integers. Okay, you'll see why. And if you solve this, you're going to get x equals -4. If it was the counting numbers, -4 is not in there. Okay, notice how it's just one number. It's finite. All right? If the domain was all the numbers given as x is less than 4, the solution set contains no elements because you can't be. Okay, can't be anything. Okay, no, actually, since it's -4, it's the same thing. Take it back. Gotta look at your problem. Okay, no, it's still 4. It's also finite. Okay, you've done this before. Just remember, if you can count, that's all it is. Now, another one is infinite sets. Okay. Like this, an inequality usually has an infinite set, okay? That means you can't count them all, right? For example, if the domain is the integer and x plus 7 is less than 2, the solution set is, if you solve it, you get x, is less than -5. Okay, well, think about it. Name numbers less than -5 that are integers. -5, -6, -7, and it goes on forever. We can't count that, okay? We can't do it, right? So that is a set that we can't actually count. Okay? Well, we can write this in a technique called set builder notation. Okay? An example of set builder notation is right here. It's read the set of all x's such that, okay, that's what this little line means, such that x is less than -4. That's this statement right there. And x is rational. Okay, so you can see all of these things are part of the statement. Okay, so if I want to write this, I could say x, the answer of x, such that x is less than -5. That states it. But we also want to put in a condition. That's what the last piece is. And in this case, we said we were part of the integers, so x is an element of the set of integers, which is the z set. Okay, and that's the way we can write that in set builder notation. So you can see finite, countable, infinite, not countable. Okay, can't list them all. All right. So just an example. Let's write these in set builder notation. We solve this. X is equal to 19. Okay, not a big deal. Solved it. Try 19, it works. Okay, x such that x equals 19, and x is an element of what did we say? The whole numbers and the whole numbers. Okay, we'll just write whole numbers this time. Okay, there it is. All right. On the other hand, we have this one here. If we solve this, it's 3y is less than 11, so y is less than 11 over 3. So if we want to write this in terms of, notice the variable changes, so it's y such that y is less than 11 over 3, but now y is an element of the natural numbers. Okay, notice this is finite, and this one is infinite. Okay. The last of these is the null set or the empty set. That means you don't have an answer. Okay, so that would be symbolized by that symbol here, or an empty set of brackets like so. Okay, if we look at the example we have here, you can see that it ain't gonna really do much. Okay. 10 minus 5x equals 15. Negative 5x equals negative 5x equals negative 5. I got x equals 1. Now, if we look at this, so far looking pretty good. Unless I can add, it's plus 5. Be careful. Your addition, you can see that we get minus 1. Now, negative 1 is not a counting number. Remember, counting numbers start at 1, so there is no solution for this. So we say it's the empty set. Now, if I change this from counting numbers to integers, now we got an answer. But you can see that. All right, continue onward. Okay, we still have some other examples we want to look at. Okay, solving equations in first degree by transposing. Okay, these are just some basic solvings. You know, there's going to be some set builder notation in here. Clean the equation of parentheses, combine like terms, collect all the variables on one side from on the left, constants on the right. That doesn't matter because of the symmetric property. Okay, and simplify, solve, and check. It hasn't changed. And for those of you who don't know this is Mega Man. Has a ton of games. Okay, good guy. Rockman in Japan, just so you know. All right, but you should know how to do this stuff. Let's just make sure you can do it. All right. The following examples, let the domain be the real numbers. Write your answers in set builder notation. Okay? Well, remember, the domain is the real numbers. That means the solutions have to be real numbers. So we're not dealing with imaginary numbers this time. Okay? Let's remind ourselves how to solve these things. Okay? 6y plus 3 equals negative 3y plus 4. Just add 3y to both sides. 9y plus 3 equals 4. Subtract 3. 9y equals 1. Divide by 9. Y equals 9. Okay? So, if we take a look now, all we gotta do is write in set builder notation, which is y such that y equals 9. And we want to give it its restriction, which is y is an element of the real numbers. And then you put those nice curly braces around it, which is a skill that takes years to develop. Okay, then you got your answer. Let's take a look at number 2 over here on the right. Okay, which is we got some parentheses here. Make sure you distribute it first. Okay, we get 2x minus 6 minus 5 equals 17 minus 4x plus 2. Notice how I distributed the negative to both of those and the 2 to both of those. All right, CLT, as I say, combine like terms. Right there, it's 2x minus 11 equals, these two are the same and they're on the same side, equals 19 minus 4x. Let's add 11 here to both sides, and then add 4x to both sides. You'll see that that cancels out. We're left with 30 on this side equals 6x. Divide by 6. And x equals my favorite number, 5. Okay. It said write it in set builder notation, so let's do that. And the final answer, I'm just going to write it up here in the top right, is x such that x equals 5. And again, we're restricted to the real numbers, which is pretty standard for us. We like to work in the real numbers. All right. Sometimes you might see it written in set builder notation to start. Don't let it scare you. All right. So all this stuff right here, you can pretty much block it out. That's not going to realize. Okay. So let's just solve this equation here. We'll start by distributing. We get 4x plus 8. 4 goes to both the x and the 2 equals -1 plus 2x plus 12. Don't forget to distribute. Yoink. Okay. CLT on the same sides, 4x plus 8 equals 2x plus 11. I'm going to subtract 8. 4x equals 2x plus 19. Oop, no, not 19. 3. Watch your adding. Subtract 2x. Get 2x equals 3. So my next step, divide by 2. X equals 2/3. Oops, sorry. Dyslexia. 3/2. Make sure you be careful on that. Simple 1-point mistake. Mess you up big time. Alright, and we'll write it as x such that x equals 3/2. And then again, comma, x is an element of the reals. Notice how the variable is x, so everything is an x in the set builder notation. Final one. N such that we have this equation. Again, this is all irrelevant. It's just telling us the variable we're using, where domain was given at the beginning. Okay. Sometimes you might see the domain written in there, like you might say n is an element of the reals or something like that. Again, don't have to worry about it when you solve. So start by distributing everything. We get 6x or 6x in x command. 6n minus 15 equals 4 times 3 is 12n minus 24. Okay. I'm going to subtract 6n because I like to keep the n's positive and therefore add 24 to those numbers. Alright. Doing that, those cancel out. This is 6n over here. That cancels out. Negative 15 plus 24 is 9. Divide by 6 so that we get that alone. And n equals 3/2. Okay, and our final answer in set builder notation. Notice how it's n such that n equals 3/2, comma, n is an element of the real numbers. Okay, so the notation hasn't changed. Same solving stuff. So be ready for that. Not a big deal, and that should help you out there. You guys have a good one. See ya.